At a very high level, there are three types of questions that are important to decision makers as they analyze data to understand what's happening in the business. For the purposes of this course, we'll use this set of questions to represent the business requirements for a business intelligence solution that we need to build. Although the scenario is extremely simple, the same principles that we're learning in this course also apply to real-world scenarios for which our users have many more questions that require answers. For example, our users want summarized information for a particular point in time, such as the total sales across a certain number of years, or the profit margin for last year. Or they want to answer questions that require comparative data from multiple groups of information or time periods, such as the difference between sales this year and last year, or breaking down the sales last year to see the profit margin by product category. There might also be questions that require consolidation of information that helps us answer questions with data from different sources, such as a comparison of sales activity with the call center demand for a selected group of customers. To understand why we incorporate analysis services into a business intelligence solution, we need to compare our experience with relational queries with OLAP queries. OLAP stands for Online Analytical Processing, by the way, which is the type of technology that analysis services is built with. We build BI solutions because business users need to get answers to questions. It's not very efficient on a whole lot of levels for IT to be responsible for producing all of the information that business users need. So a common way to get started with business intelligence is to turn the users loose on the data. But these kinds of queries can be problematic if we try to get the data from a relational engine. The problem is that we're turning them loose on the same database that's being used to keep the business running. So if users are asking those questions, we run into a resource contention problem because summarized queries are grinding away and interfering with inserts and updates that are occurring at the same time. Another problem is the fact that data sources are often focused on the here and now. Historical data gets archived after a while, or if it needs to be available, it might be kept at a summarized level only. Then we have problems with calculations. Amazingly enough, people who work for the same company will take a different approach to applying calculations to data, which can be problematic when two people want to discuss results at a meeting and bring their own reports that have completely different answers. And then, the structure of the data source is often in the third normal form, spread out across multiple tables and requiring complex queries that can be difficult to write and containing lots of joins that can cause queries to run slowly. OLAP can help us solve these problems. For one thing, having a separate data source to query reduces resource contention. And another benefit is that we can keep historical data in our OLAP database that might be otherwise eliminated by overwrites or archiving in our source system. A more significant benefit of OLAP is the ability to centralize business logic so that we get the same answer to a particular type of query no matter when we ask the question and no matter who asks the question. Furthermore, the way that Analysis Services stores the data is designed for fast retrieval of data, and many times we can write simpler queries once we learn the query syntax for Analysis Services, so that we can write perhaps 20 lines of code instead of 100 lines of code to answer a question.